All right, everybody. It's happening. We're live. Thank you so much to the Apollo team for helping me out with using a computer. That's awesome. I want to welcome everybody officially to the GraphQL production ready GraphQL session. I am so happy to see you all. Hey, everybody. It's happening. So I'm super stoked to be here. We are going to have a lot of fun talking about all things GraphQL. And why don't we just get started? We have delayed long enough. So my name is Eve Porcello. I'm super excited to be here. You can always reach out to me with any questions that you have. Eve at Moon Highway is my email address, at Eve Porcello online. I'm coming to you live from Tahoe City, California. I have created some courses for LinkedIn Learning and Egghead.io, and we've written a couple of books about GraphQL and React. So today is all about kind of taking what we know about GraphQL already and building on it with this awesome ecosystem of GraphQL tools. So we're going to start out by getting acquainted with some of the latest features of the GraphQL spec. I guess upcoming features is a better way to say that. We also have a session on or a section on schema design, Apollo Studio, Rover CLI, error handling, caching, all sorts of fun things. What else can I tell you? So if you have any questions at all, feel free to share those in the chat. I have that up on my screen here, so I will be monitoring that throughout. And here's a look at our timing for today. So we're going to get started. I'm starting a teensy little bit late, but we're going to be taking some breaks throughout so that we are able to get all of this fun knowledge into our heads. And then we should be wrapping up at around 11:30. So keep the questions coming. I will stay on top of those as we move through. Okay. So what we are going to talk about first today is defer and stream. So to get us into the mood for this, I want to talk a little bit about a philosophical question, which is, how do we get things done? In general, how do we get things done? How do we reach our goals? How do we make things happen? My birthday is January 2nd. It's the day after New Year's. So I feel like I'm always very consumed with New Year's resolutions and self-improvement at the beginning of the year. So every time one of these events comes along, one of these birthdays comes along, I think, okay, here's what I'm going to do. I'm going to exercise every morning at 5:30. Yeah, exactly. Let's go, Capricorns. I'm going to cook delicious vegan meals every night. I'll meditate 3 times a day. I will triple our business. And then I will call my worst relatives once a week. Then by January 3rd, the next day, I'm eating ice cream for dinner and everything has gone fully out the window because I've basically overpromised what I'm going to do. And I'm trying to do too much at once. Happy birthday, January 4th. I like it. So we can think about this kind of overload of information, of plans, of goals, etc. We can think about this as it relates to GraphQL. So from our clients, of course, we always send these GraphQL queries to our GraphQL APIs in front of our data sources. Our data is then collected by that GraphQL API. And we also have a way of doing this with Apollo Federation, with a gateway in front of all of our various GraphQL data sources. So we want to think about when we are fetching data or when we're trying to get things done, how a query does it. So let's talk about how a query does it. We know this already, but we'll get it into our heads to start out the day. Every time we ask for some data from a GraphQL API, we're going to send a query. Then we're going to get back a big blob of data, and that's that. Our query matches our data exactly. So that's how a query gets things done. And a mutation gets things done by sending a mutation and getting back another blob of data. All of these are HTTP requests. We're asking for the data from our single GraphQL API. And then finally, we have GraphQL subscriptions, which are going to be sent over WebSockets. We'll send a subscription, and then we'll get back a bunch of blobs of JSON data anytime that data changes. So these are kind of the ways that we get things done in GraphQL. We have a query where we are reading some data. We have a mutation where we are writing some data, followed by a fetch for grabbing a little bit more data. And then subscriptions, we have the ability to listen for data changes in real time. So we're waiting on all of that data to come back. So, you're asking about, are the slides available? Absolutely. So I'm going to share with you a whole repo of a ton of different files and a ton of stuff that you'll be able to use. So more on that in a second. So let's think about a query. We got a ton of different fields, right? We have a name, location, birth location, all these different fields on a cat. And the traditional way that we will send this query is that we're going to ask for all of this data and get it back in a single response. So we're basically saying, let's do all of this at one time, just like my New Year's resolution. And that's a lot of effort. And it might be more successful if we broke it down into smaller chunks. So instead of me being so ambitious on January 2nd and falling apart on January 3rd, we're going to break it down. You hate the cat. I love the cat. I'm very offended by that. Just joking. Okay, so we have our query. We are going to break down our query into little pieces. So let's think about how we might do this. A cat, our biscuit cat here, all we really care about at the beginning is the name, the location, and the birth location. So we're breaking it down. We're getting those fields that we need right up top. And then what if there was a way to put off or wait for those extra fields until they're ready? We'll display some data to our user first, but then we'll hang out, we'll be patient for the rest. And yes, some interesting information for a cat, right? Astrological sign. We're all putting together astrological charts for our cats, right? So I posed the question, what if we could do this? And the answer is we totally can. And that's with the emergence of these two awesome directives, defer and stream. So this is an old awesome GIF that was part of a blog on Apollo's site in, I think, 2016. The idea of defer and stream have been around for a long time. They've been bubbling up in the ecosystem for a while. But the whole idea of the defer directive means that we'll load the data that's most important at the top of the page, check it out, and then the subsequent data will be loaded later. Versus the GIF on the left-hand side, where we're waiting on all of this data to load first and then displaying it. So a better user experience is we can break out that flow so that something displays to our user right away. The way that this looks inside of a query is this. So we have our cat, all of the important fields are listed up top. Then we create a GraphQL fragment for a wrapper around a bunch of different fields that we might need later. And then we're going to use that @defer directive on the fragment to get that to load. Okay. Stream is another one of these awesome directives. So let's say we have Biscuit, and there's a lot of questions about Biscuit the cat. What school does he go to, and where did they learn to ride a bike? That's a really good question. We're going to have to get into the data for that to dig deep, but cats ride bikes, I think. Bike riding dental school for cats. Exactly. You got it. right, cool. So let's talk about the stream directive for a minute before I show you a demo of all of this stuff. We have our cat named Biscuit, but Biscuit has a ton of friends. Biscuit made a lot of friends at Cat Dental School. And what we want to do here is we want to intelligently load them so that we're not having to load too much data at once. So Biscuit has these friends, and Biscuit's popular. He has a ton of different friends. So what we can do here is we can add what's called the @stream directive. We can specify an initial count, so a certain number of pets that is going to load first. And then we can load 3 at a time as more and more cats become available. So what's extra cool about this is we can even defer fields that are part of the stream. So maybe we have a bunch of friends of Biscuits, and then we want some of that less important data. We want whether or not the cats are dentists, et cetera, et cetera. So we're going to add @defer to all of these extra fields and use them in combo. All right. So I'm going to show you a demo of this, but there are places that you can experiment with some of this code. So I'm going to copy a link here. I'm going to paste that into our chat. There's something called the GraphQL Bleeding Edge Playground, which is kind of an exciting name. And what's cool about this is you can test out some of these new GraphQL features before they're actually added to the spec. But in general, we're just trying to prevent people from seeing this screen. We're trying to make it such that people aren't just like waiting on all of this data that they really want to see. Instead, we can break down that data fetching story into different chunks so that people are getting access to data at all times. Must have some sharp engineers working on it. Totally. So I'm going to share with you this link to so let's talk about a couple different things. So in general, just getting us all on the same page, GraphQL, as we know, is a spec. It's this living, breathing document where we're constantly thinking about collaborating on new features. What I just shared with you is a link to the GraphQL spec edits issue here. And what you can do with this is kind of track the progress of how defer and stream work. You also will see in our next slide here, and we'll check this out here. Let me make sure that we are linking to the right place. We are. So we got Express GraphQL, right? This is one of those awesome GraphQL libraries. You can check this out today. So you could play around with this today. The really good question that Jenny asked, are these features already available? If not, when? I would love to start using it now. So yeah, you can experiment with using it right away, either using the Bleeding Edge Playground or Express GraphQL or GraphQL.js. Throughout the next year or so, I would think that most of our favorite server libraries, like Apollo Server, will be implementing this and making sure that all of this is supported. So you can check out So you can check out the Apollo Server project for defer support and stream support as well. And this will really relate to our front ends. So we'll be writing a lot of queries that utilize defer and stream also. Okay. So thanks everybody for sharing awesome links. I love it. Y'all are killing it at link sharing. I will share this other one. And Taylor asks, seems like these directives aim to solve the same type of data fetching issue as React Suspense potentially. Any thoughts for future use of when to pick one technique over the other? So yeah, I would say in general that all of our it lines up really nicely, right? We have concurrent mode and the possible future of React Suspense, where we're thinking about breaking down our data needs into smaller and smaller chunks. So I think everything will kind of be moving in this direction as we move forward. I think that GraphQL giving us a nice way of linking our components with our data fetching logic and requirements is going to be a really powerful thing. I'll show you in a second how this looks in an actual project. And let's go ahead and transform. And yeah, David says, I'm glad we're getting the hot Apollo goss. I'm in the right channel for it. Defer and stream isn't officially in GraphQL.js yet, but we're aiming to support it in Apollo server as one of our next big projects. Awesome. So yeah, I think this is being played around with on branches in some of these larger projects, but it's something that will be, it'll be a big deal. So let me show you what this looks like in one of these projects. So I'm going to, let's see, I'm going to start our server and I'm going to start our client here. And this is just using a demo from the link I shared with you before, the GraphQL Bleeding Edge Playground. And let me pull up the graphical interface over here. So we are so used to seeing GraphQL Playground and now Apollo Studio Explorer that this is such a weird site, but we have GraphQL here and we can start to send a couple of these queries. So let me show you what this might look like in a little query editor here. So the first thing I'm going to do is I'm going to send a query called defer test, and I'm going to ask for a name. Pretty straightforward. I send the query, it sends an HTTP request, I get back a blob of data that's the exact same shape. Now, I want to ask for another field here called exciting data. As we would probably imagine, exciting data is going to be something that we have to wait a little longer for. It's going to be a field that we have to wait a little bit longer to fulfill. So I click on the play button, I'm waiting, and then I get back everything. And it says it's worth the wait, which I tend to agree with. But I think we can make this loading situation a little bit nicer. Check this out. We're going to write a fragment called later fields. And we're going to define this on a particular type. And this time we want to put the exciting data field in the fragment. So now let's replace exciting data in the initial query with ... later fields. And we're going to add the @defer directive right after the name of the fragment. So when we click play, check it out. It says has next. Has next has been added to the response object. And then we get back the second piece of data when it's ready. So has next, again, will be added to our response. When it's true, it means more data is coming. When it's false, it means we have all of that data. Pretty cool, right? So that's the defer directive. We can add on to this a little bit more by testing out a stream. So think about defer as being breaking down a request where an object might load certain fields first and then some other fields later. Yeah, I couldn't agree more. Very cool, very exciting, and you can think about all of the ways that this might be useful. So yeah, the data just lazy loads automatically in the response. Yeah, so we're gonna, in our resolver functions, define the logic for how we want that to work. So when the data is ready, we can use some asynchronous functions to make this work and pull back that data when it's ready. Other questions. Is this better than using pagination using Apollo cursors? I would say that pagination is more for, you can use them in combination. So with an example like this, maybe we have a list of different items that we want to load, a list of tweets, for example. We might use pagination to say, give me the first 10, And then as I ask for more pages directly, either by scrolling or by clicking next, then go ahead and load those when they're available. On the other hand, defer is being used to break down these objects. Let's say it is a tweet. Maybe a tweet is a bad example. Yeah, a tweet is a good example. So we'll have a photo, right? And then a name. And then underneath that is the tweet. Maybe the tweet is the thing that's deferred. It comes a little bit later. Pretty cool. Other thoughts that are coming up, is this working over WebSockets? This feels like it's working over WebSockets, right? Where it feels like the pattern of subscriptions where we're listening for some data, but it's actually working over HTTP. So we are still going to use the HTTP architecture that we're familiar with, queries, get data. So a query will have those fields. So I don't know exactly how. So the way that this will work with resolvers, for example, in Apollo server and in these other server libraries, is that you'll just write this logic in those resolvers. Let's see. Awesome questions, everybody. This is fun. Cool. So great question here. If I was doing this via use query in React, how would I succinctly differentiate between the two sets of returned objects? Would you use a use effect dependent on the returned object and then set state based on the returned data? Maybe. I would say that we're not quite there yet with that approach, but I would assume so. Having said that, our data is going to, we just want to think about our data as being more of a stream and less of a single response. Streaming just meaning we're listening for more data. We're defining in our resolver how much data we should be returned. And yeah, this is going to work in all of our client tools, all of our server tools. I'm giving you this as a preview of something to get stoked about, to get excited about for the future. But we can start to think about how this will work for our own data fetching. So we've talked about defer, right? Defer, thinking about breaking down our objects into different chunks to load when the data is ready. But we also will have access to a stream. So check this out. I have a query, and I'm trying to keep it super simple. I have a query called stream test. Now the stream test query, think about a stream directive as being used for lists. Lists are going to be used with streams because we're going to specify a certain number of items that we want to load first, and then we'll get subsequent items later. So check this out. We're going to say at stream. We're going to specify an initial count. And let's just specify an initial count of 1. The stream test is going to return an array of strings. So let's watch how this plays out. It says what's, it says up, and then it says friends. Similar to our defer, having the has next property is going to tell us that there is more data to come. So the has next property is super important. We're going to be able to, anytime has next is true, we're going to be expecting more data to be rendered in the front end. This is something that, again, it's coming. It's not here exactly yet. You can experiment with this stuff. However, it's a really nice approach. So defer, we're thinking about breaking down our objects and loading later fields later, the slower to load fields later. A lot of times we talk about like things below the fold. I don't know if that works in all cases because websites aren't newspapers, but you get the idea. We're loading some data in the background. Okay. So let's go ahead and go back for the moment. Someone had asked for the link to the GraphQL JS project. So I will share that here. The other is Express GraphQL. Again, these are working on different branches. So if you want to check out these different branches, you can, just to see how this stuff is implemented. And yeah, Hugh has given us the more Apollo hot goss that Differ and Stream are coming to Apollo client and server very soon. So a couple things to think about for our Differ and Stream. This stuff is coming. Don't panic too much about the implementation. These libraries are going to use the spec to guide their approaches. And let's see, they are going to work over lambdas and all of the ways that we use them now because they work with asynchronous functions and resolvers. So that is a look at our Differ and Stream. What I'd like to do next is I want to point you in the direction of the student files for the class. People were wondering about that. Is there a repo? Of course, there's a repo. So let's see. See if I remember what that repo is called. I do. There we go. Okay, so here's what I'd like you to do. I know there's some more questions about our Differ and Stream, but I want to point you in the direction of the resources in this repo. There are links to slides. These are the ones we covered so far. There's also a link to the Schema Design slides that we'll be getting to in a second. The links about Differ and Stream are added here too. And then each one of our sections of the course, and I'll be adding more links to this too, because a lot of times people will ask questions that lead us into fun tangents that we can add for everybody's resources. Inside of all of these folders, you'll have start and finish files or sample projects that you can run when appropriate. Okay. Cool. So if anybody has any trouble accessing that, do let me know. But I'll give you a second to pull up that repo and download it. Cool. And let's see, David is saying the recommended transport for a Differ stream is a multi-part mixed response. I don't know if Lambda lets you incrementally create such a response, but I doubt it. Yeah, that makes sense. I think in general, yeah, this will be an interesting approach. Thinking about, we all came to GraphQL for efficient data fetching, right? And breaking down our already efficient queries into smaller chunks is going to be really interesting. And then Steve said, hi, Steve, by the way, just theorizing, but libraries will probably use promises or async await strategies and implementations and manage streaming protocols in the background. Yeah, totally. So that's how the functions on the back end of my demo work, are just with async await. And so very good. So yes, what we're accessing now, I'll share the link again, is a link to our production ready GraphQL repo. This contains everything that we will need for this course. I will also, I will also add to this as time goes on. Okay. So let me open this up. I'm going to take a look at our repo in VS Code. And go ahead and check out the section on schema design. Okay. So a lot of nice conversations going on about our discussion of defer and stream. If you're interested in more, check out those links that are in your student files, because you can check out the status of the project and go deeper on any of those things. And also, also try to check out how that stuff works. You can run everything if you'd like to. All right. So let's talk a little bit about our schema design section. This whole section of our course is going to be dedicated to collaborating on updating a schema to make it readier for production and make it better all around. So what I'd like to do is we're going to take a look at the slides to get us started. So we're going to be able to find those in our student files as well, of course. And this will be your opportunity to share your opinions on how to iterate on a schema as well. And I'll give you some tips and tricks along the way. Okay. So let's talk about a schema. So we have a schema inside of our student files, inside of the schema design start typedefs.graphql. That's all about these pets. So we have a pet type, we have a customer type, and then a few different fields from there. And what we are tasked with doing today is taking our existing schema and updating it to make it better. Some things to keep in mind before we embark on this project is we want to think about, with any schema design project that we're working on, what do the clients need? So what data do the clients need? Are we just defining a bunch of fields that map to a database or a REST API that we never use those fields? Or are we actually thinking about the clients? We also want to be thinking about specific, consistent naming that's readable and sensible to anyone who is consuming our API. And then finally, we want to be thinking about, if possible, how do we create custom objects over scalar values? So those are things to keep in mind. But inside of our schema here, we have an enumeration type called pet category. Inside that pet category, there's a dog, a cat, a stingray, and a rabbit. Now, this is a pretty good approach. But what happens if I want to add some sort of pet to the enumeration type? I'll have to add it there. And I also am going to potentially have a difficult time defining custom fields on each of these pets. So a cat might have a curious Boolean, but a rabbit doesn't share that. A rabbit is neither curious nor not curious. A stingray might have a chill or a fast Boolean, but we don't want to give that similarly to a dog. And then what happens when we add our horse? That horse might have special properties, special qualities that are added to that specific type, and the enumeration type might not be sufficient to describe it. So what we're going to do is we're going to update our pet type to a GraphQL interface. And the interface is going to create a bunch of different implementations of this pet type. And then from there, what I can do is I can add different custom fields to each one of those. And then where it says TBD future pet, I'm going to be able to add custom fields to maybe the future pets that I add. Maybe we add a new pet in the future. There are custom fields on that. We will share the initial properties of the pet, but then we can add on to that too. Okay. Similarly, we may want to create some union types inside of our schema. So we have our union called a family pet, which is either a cat or a dog. And then we may have other types of unions for different types of pets. And we define this by just adding a pipe between the different types. And then when we query, we're going to use an inline fragment to make this work. So what I want to do is make some enhancements to our schema based on that conversation. Again, we'll open up the typedefs.graphql. And let's zoom way in on this. Let's also make sure that we have our dependencies installed in this folder. So I'm going to type cd. I'm going to drag the start folder over here, and then we'll run npm install. So once I've done that, if we take a look at our server, it's pretty straightforward. We just have a new Apollo server where we're defining some mocks as true. If you haven't used this feature before, how cool is that? We're using the power of the schema definition language to give us this awesome type system for our API. Maybe I don't have my data sources wired up yet, and that's totally fine. I can still build out my front-end prototypes. I can still build out our schema. I can iterate on that schema until we all get it right before locking it into a permanent state. Okay. So even though we are not all in a classroom together right now, I do want everybody to, yeah, isn't that cool that you can drag a folder into the terminal? I totally stole that from a terminal I just saw. Yeah, so, or a class I saw. So I copied that from a terminal I saw. That's technically true, but that makes no sense. So yeah, it's under o2-schema-design under start. Here we have an index file. And again, we have a property here called mocks true. This is going to allow us to, number one, run our server with our current schema. And then we're going to be able to iterate on this schema until we get it right. And then we will move on from there. So let's go ahead and make some adjustments to this. And thanks everybody for your awesome questions. I appreciate you. So yeah, let's talk about what mocking is a little bit more if you haven't worked with that before. So think about a mock as being a way of returning some fake data for a field. In any GraphQL project, we have a document called a schema. The schema is a type system for our API. Anytime I have a pet, right, it has an ID, a name, a weight, a category. So what's super sweet about this, let me run npm start to run this. Oh, of course, I have something running. Let's say goodbye to defer and stream and hello to our schema. I'll go to localhost 4000. And on localhost 4000, it will pop open Apollo Studios Explorer for us, which is sweet. And now check it out. If I send a query, let me collapse that a little bit. When I send a query, we have, let's say, a query for all pets, right? ID and name. Now, I haven't set up my resolver functions. I haven't defined any logic for how my data is being returned. So when I click run, I'm going to get back some fake data, some mock data, some dummy data. That's a little derogatory. But this is going to return some sort of value for an ID and then some sort of a string value for the name. So it's just going to look at what are all of these fields and return based on that. And if you're interested, I can show you some mocking techniques that we can add on to this in a little bit. One of the things you're probably thinking is, why do we have only 2 responses? And that's just because when we set up mocks with Apollo server, the default is to return two objects in a list, but we can always change that if we want to. Okay. So let's go back to our schema. Awesome, Jenny. The Odyssey series also covers creating mock data in your resolvers. Excellent. So Yeah, the Odyssey series, what an amazing thing, right? So, line 3. Yes. So another great question is totally. Do mocks work similarly in Apollo Federation? Yes, absolutely. So anytime you have a schema, it's a pretty mockable thing. It's a strict type system that is going to define what your types are. But remember, what we're trying to do here is we're trying to enhance our schema in order to make this a little bit more extensible and to make this readier for production. There are lots of changes we could make to this, but let's start with this one. I'm going to first change our pet to an interface. Think of an interface like being a class. A class has certain fields on it, certain shared fields. And I'm also going to, with our interface, get rid of this field called category because I'm going to represent different types of pets as implementations of this interface. So check it out. I'm going to say type pet or type cat rather, implements pet. Now, don't be upset with the messenger on this, but anytime we create an implementation of an interface, Jenny, dogs are coming soon, I promise. Anytime we create an implementation of an interface, we need to copy all of the fields from the base interface, the main class, into our implementation. The reason for this is because we need to define specifically which fields should go here, and then we can add on. So we could say sleep amount, int, and then whether or not the cat is curious, which will be a Boolean. We then are going to define different types for all of these different pets that we want to make available at this pet library. So, as promised, let's go ahead and copy. Well, let's copy the interface because that's maybe a better way to do it. We'll copy the interface. We will drop this here. So I'll say type dog implements pet. So everyone is, yes, I'm being shot as the messenger. Totally. Okay. So hear me out. This is why I think this is the reason. So we are going to, there's no sense of like injecting these fields into individual pets. We're going to keep in mind only write our schema once. So this is going to pop those in there. This is going to, let's see, everyone is. Sebastian says there's some benefit of structure for this. And I think that's totally, totally fair. We're being very specific about which fields are being added to each one of these types. The whole idea here is that, and Javier says this too, the idea is we're trying to be very declarative when we are defining our types. Even though there is a little bit of extra effort on this, it's going to serve us well to document our schema correctly. So yeah, a lot of folks are in various stages of acceptance of this, but I'm just passing along the info for you. So let's add on to this a little bit. So we got our cat, right? We are going to add some fields for a dog. What fields should a dog have? And we'll show that error in just a second. I've taught a lot of GraphQL classes in my lifetime, and people get mad at me when I talk about interfaces. So cool. What fields should a dog have? What field should a rabbit have? Bandana color. I love it. We'll just make that a strat can fetch. I like it. We'll make that a Boolean. Drool level. I love it. Cool. I made that at like Halloween Boolean. Too many O's. Anyway, rabbits. What do we got for rabbits? Kind of like obedient for a rabbit, because obedient. We'll make that a Boolean. And all of you are fun today. Let's create one other type just for funsies. We'll make a stingray too. We're going to grab all those fields, whether we like it or not, from the interface, because we love to be declarative and specific when we're documenting our API. And then we will add favorite. How about like caret? We're all on the same page with that. Likes caret. I'm making typos. Can swim. That's very funny. Hopefully they can swim. Let's talk about that. Is teacher. Oh man. Okay. So those are good. So what we're thinking about with our schema is a pet is a pet. A pet has certain fields on it that a cat will have, a dog will have, a rabbit will have, and a stingray will have. We do want to add some custom fields, though, for each one of these pets, because while they are sharing a lot in common, they do differ in some areas. Think about that as being like a user, right? You might have a base interface called a user, and then you have different types of user authentication rules where there are different fields for each. A couple comments that are coming up are, why are we making all of these fields required? Anytime we see an exclamation mark, that means that a field is required. And for that, I would say you can decide whether or not, for anything, whether a field should actually be non-nullable or not. A good rule of thumb with that I've found is don't make a field required unless you absolutely need that. So let's take a look. I'm sorry that some folks cannot hear. So let's take a look at what this looks like in our schema. Something that's cool about using the built-in Apollo Studio Explorer that ships with Apollo Server 3 is that we're constantly refreshing our API in the background. I don't know why I just hit refresh. That was a weird thing to do when I was saying that. Okay, so let's take a look at our documentation here. We have a list of pets, and then we have these fields that are available on these pets. So the way that we're going to do this in our schema is we're going to add to this a couple different things. So let's try to run this. This will give us these fields on the pet. And then if we wanted to add some fields for specific types, we can definitely do so. The final thing I need to do here, though, is we have our pet interface, right? So if I scroll down to our pets, it still should be returning that pet type. It's also a possibility, now that we've created cats, we've created dogs, we've created rabbits and stingrays, we could create some custom queries for these types. So we could say all cats, we could say all available pets, etc., etc. So the other thing I want to point out here, a couple questions that are coming up. So mocks don't seem to figure out dates. So yeah, the dates will probably just look like a string in our mocked data. It will return something. Now, if you wanted to create a custom mock for a date, you certainly could. And I'm going to write a note to show you how to mock a list and to create some custom mocks, just in case you're interested, because we have gotten a few questions about that. Sweet. So the other thing I want to add to our schema here is I want to add a couple of union types. Oh, it just blows up. Well, Ken, guess what? We're going to take a look at that now then, because we don't want things to blow up, right? All right, cool. So friends, let's go ahead and fix that now. The first thing we want to do for that is we're going to make some adjustments to our Apollo server constructor. Now, the Apollo server constructor here is currently, we're just saying mocks true. Now, we can remove true from this, and instead of just going with whatever those defaults are, we're going to override the defaults with our own functions. So check this out. We will say const mocks, and we can create an object of different mocks for different types. So for example, we could say like int. Every time I ask for an int, I want to return 6. Anytime I ask for a string, I want to return cool pet. I don't know. And then for date, what we want to do is return something. So we could just say like 01, 02, 2021. Remember I said that's my birthday. I'm very creative. So this is what that would look like in that response. Okay. So here's what I want to do. I'm going to open up our type defs once more. I also want to remind you that there's a finished folder that has a typedefs.graphql file in it. If you get stuck at any step in this process, you can feel free to check that out. But I think let's take a little break. We're going to take about a 10-minute break. When we return, we're going to go deeper on these mocks. We're going to test this stuff out. We're going to, Patrick had asked Will a mock of the pet array. I'm like, array. Those are square brackets. The pet array, very hard to talk sometimes, will return just 2 items. I will show you how to return more. But there's a lot more to come. So why don't we take a pause? I'm going to put a timer up on the screen. If any questions pop up during the break, I will answer them as soon as we get back. I like to give people an actual break so they don't feel like they're missing something. But I will see you back here in 10. All right, everybody. Welcome back. Thanks for coming back. That's always nice. Before the break, we talked a little bit about how to set up mocks, and I want to continue along that conversation and also make some other adjustments to our schema to make this a little bit better. So what I'd like to start out with is we should be using the mocks object and sort of injecting these mocks into our running server. A couple things to think about. Let's see. It looks like people got tacos for their break. That sounds awesome. It's only 9:40, but I would be extremely willing to eat tacos at this time. So, what I'd like to do is let's go back to our type definitions for the moment. And I'm going to make sure that our server is running on localhost 4000. What we did before was we changed our pet type into a pet interface. And now we want to make some additional changes to this to represent some of our other types. So thing one we want to do is we want to create a family pet. 640 there. That's good. That's a more socially acceptable time to eat tacos. So we're going to create a union type called a family pet. Then we're going to create another union called an exotic pet, which will be either a rabbit or a stingray. That's kind of funny to call a rabbit. What a wild pet that is. But the whole idea behind creating a union type versus just a regular type is that we can return a list of multiple types. So if we scroll down to our query type, and let me move this down to right above that, so we can actually see stuff. We're going to add here a family pet. So here we're going to say, let's return a list of these family pets. Similarly, we'll do the same for exotic pets. So not only has the addition of this type, and this needs to be a capital E, I'm sorry. Not only has the addition of this union type made it such that we can return a list of multiple types, but it also is going to allow us to ensure, yeah, exactly. Renaming project to Tiger King. Yeah, BRB, change that. I'm very sorry. I should have made that better. I think there's going to be a season 2. Isn't that something I heard recently? That's a fact that's littering my head. So we have a list of all of these. Is a mascot cat, dog, rabbit, etc.? Yeah, exactly. So all of these are great ways of just making our data a little bit more searchable in a different way. Okay. So that's that with our union type. The other thing I want to point out here is that as we are coming up with our schema and mocking these different fields, I think a really nice thing to do before we start writing any resolvers is to start to think about how we can make this better before we start committing anything to actual apps. So here's what I'd like you to do. Using the schema that we have here, using all of the things that you know about schema design already. And if this is the first schema that you've seen in your life, you have seen words in your life. So there might be better ways of describing some of these fields. So what I'd like you to do, let's take the next maybe 2 or 3 minutes. We're going to take a look at our schema and make a suggestion for something to change. We're all collaborating on this. It's an open forum for collaboration. And then we can talk about like why we would make those changes. So whenever you're ready, go ahead and drop your suggestion into the chat. Christopher isn't sure if he's ready for a season 2. Yeah, I know. I feel similarly. Maybe we got what we needed from that in season 1. Cool. So, Kate, I love your suggestion. I'm gonna be quiet while people think of their ideas, but we'll go over that in just a second. Yeah, totally. Sorry. And I'll scroll down to the union types we just created. I love what everyone is coming up with so far. What is a pet due date? So this app is for checking in and checking out pets like they're books from a library. So we could potentially go check out a stingray for the weekend. So the due date is just when we have to bring it back. Very normal thing. Yeah, so if you missed the repo for the class, it's pinned at the top, but I'll share it again. I'm going to copy this link address here and share it. So the finished code is in the finished folder. Okay. So thanks for your awesome suggestions. Keep them coming. One thing I wanted to do before we get to those is I'm struggling with something in our setup. So I wanted to fix that before we continue. So what I want to do is I'm going to stop our server for a second. I'm going to npm install Nodemon, which will restart our server for anytime I make changes. What I'll do next is, now that this is installed, yeah, exactly. I'm going to type Nodemon. So a fun fact that I realized the hard way about working with Nodemon on these projects is that you have to pass an extension of an extensions list of all the file types you want to watch for restarting. So for example, GraphQL, JavaScript, and JSON. If you're using any type of file that isn't JavaScript or JSON, you need to add this. And then this is going to watch all of those files for you. So now what I can do is try that again. Oh, I just installed Nodemon again. I'll try npm start again. That's going to start that project. This is going to start to tell me that I don't know how to write code. I forgot to save this. So this should run that again. So all of these are working. So yeah, this tip, I was always like, and today too, I guess. Why isn't this working? And so that is awesome. Okay, so let's scroll back up and exactly. Let's scroll back up a little bit and go through some of these awesome ideas that I'm seeing from folks. There's tons of different ways that we can add more quality to our schemas. So Kate won first in on the schema tips, and I love what she said. Remove the pet category enumeration type. It's redundant now with the interface design. Awesome. So yeah, because we have the pet category being sort of defined as individual implementations of each of these interfaces, we can get rid of that. Perfect. Other ideas. Let's see, pet category. So we'll make sure that all pets category is no longer in our arguments here on line 109. And if we wanted to, we could move some different pets into this as well. So you could create different queries for different pets. There's a suggestion for, let's see, using lists in production hurt a bit in my experience. One has to be conscious about the cardinality of those lists. When something is boundless or can have a high number of objects in a list, it's better to use relay connections. Yeah. So you could use, let's send a link to it, the relay spec. There are a lot of different pagination strategies in general. One of the more popular ones of these is the relay cursor connection spec, where we're returning these custom objects instead of returning just regular types. So what I would mean by that is maybe we'll return a custom object that has some pets on it, but also has a cursor that points to where in that list the pet actually lives. So that's an idea. I love that. What else? Would it be better to separate due dates from pets as it would limit scalability? Yeah, sure. We could point to those instead. I like it. What else? Maybe rename pet to animal. I like that too. That's a good idea. Let's take a look at a few of these others. Add a filter parameter on all pets to filter by union type or individual pet type. Totally. You could also do something like this. You could say all cats, and just return a list of cats, which could be kind of cool. I think when we're defining our queries, naming things is super important. So ensuring that we're naming these fields something that's readable, that's understandable is super important. An older version of me used to create a lot of queries like this, which I think is fine. But I think it's nice to call it like pet by ID, find pet by ID. Does anyone have a better name for how they would want to select an individual pet? We are here to collaborate, not to have me boss you around. All right, cool. So let's see. I think it's just because I didn't save this. This should reload okay. Nice. Yeah, I tend to like find pet by ID too. Just because it's super clear. There's that old UX book, not that old, UX book, Don't Make Me Think. I think that axiom applies to, I think that applies to designing a schema as well. Get pet, but I don't like it. I like that. Seems resty. I agree with that too. So sometimes we prefer like pet by ID. It does feel a little. And yeah, it could return an optional pet, or you could add some error handling inside of your resolver to make that work. Yeah, Chris, I like that too. Leaving that off is probably a good idea since we don't have find pets or find customers, etc. Yeah. And David, as mentioned here, depends if you want it to fail if it's not found. Yeah. I like it. So let's see. Why ID like this instead of input type? Also a possibility. I think input type just would typically an input type is used for more than one field, but up to you. Yeah. Joey likes just pet. I like that too. I think in general, yeah, exactly. I love everyone's opinions on this. I think we could talk about the naming of this one field all day, but I think that's an important thing. Starting with a conversation about what should be in the schema, it's not something you can rush through, and it will change. But as we know, it's hard. It's harder to change fields in a schema later sometimes. So, okay, cool. So other ways that we can get fields are to the input type, you say, makes it easy to evolve the mutation. Yeah, I could see that. So input at fields. Yeah, I think so, Brian. Isn't it nice to take some time to do some bike shedding of names? Yeah, this is what we're going to do for the rest of the class is just decide what to call this field. So I'm just kidding. I would never do that, but it is important to talk about it. Okay. Uh, do you use different verbs for fetching, querying, loading from a data store versus third-party API? Could be useful to understand where the data is coming from. Interesting. Yeah, that's a good question. Yeah, and if anybody has any thoughts on that, go for it. Chris, I like to order queries alphabetically too. I love it. I feel good about that. So yeah, once you are comfortable with the queries that you have, or you can start to alphabetize these. Um, yeah, I think it's super useful to do this. So no shade on keeping it alphabetical. All right, cool. I messed that all up. Did I not? I did. Okay, cool. So couple other thoughts that have come up in our chat. At my company, we usually have three types of queries for everything: resource by ID, resource by IDs, and search resource. And we found that this is all we ever need. Okay. Yeah, I would say that alphabetizing these, organizing these is really based on how you approach your schema at your own company. However, naming things in a consistent way, in a way that makes it easier for consumers to access that data, is really useful. So hook yourself up later, make yourself happy and not confused later whenever possible. Okay. So because I wasn't getting my server to restart, I thought I forgot how to mock data in GraphQL, but I didn't. We know how to do that. So let's take a little look at some of these. Actually, can you show us how we can validate some custom rules for our schema design? Maybe point to a link. Yes, absolutely. So I will share a good schema design link and add it to your student files as well. Another comment here, normally I split the files for each category by instance, type, query, pet related, custom related, etc., etc. And then on that note, I would say that some people really like to break down their schema into, let me go back, into different files by type. So maybe all of our customer queries are together, all of our customer information is together. Sometimes people will struggle to have things in different files and break things down. But I would say probably just start by creating a single file and then break it down when you need to. I think that's a good rule of thumb in general for all programming, but that's just me. Okay, cool. So other things we want to talk about are, you'd asked, Javier, about how much field level documentation comments do you consider enough, but not too much? Good question. So once we've created our schema, the next step is to think about how to document this schema. So schema documentation is a really important conversation. So a lot of folks will call GraphQL API self-documenting, and that's a little bit of a misconception. We do obviously have the awesome schema documentation panel, 2 screens. Do I know how to do it? I do. There we are. So in our documentation panel here, this is showing us all of the queries that are available. So right off the bat, we can use this to build our query, adding fields whenever we need them. Boom. But we don't have any descriptions. So it says no description. If you haven't added these before, I would highly recommend adding them. So the way that I typically document the schema is with, for each type or interface or top level type, whatever you want to call it, you can use 3 double quotes to open the comment and then 3 double quotes to close it. Again, don't shoot the messenger on that one. I didn't invent that syntax. I will then use this space to write some documentation. What I usually like to think about when writing this documentation for the real world or more real world projects that I'm working on is, what do I expect a consumer of my API to know? What do I want them to know so that they can be the fastest, most efficient version of themselves that they can be? So here in this space, we can just say a pet is is the main type at the pet library. This interface is implemented by several subtypes: cat, dog, rabbit, and stingray. I don't have any hard rules for how long this should be, but it should be descriptive enough so that if someone wanders into a computer sometime and they know nothing about your API, it should be enough to communicate what you're trying to say. Let's see. Yeah, so cool. So let's take a look at this. Sorry, I was reading comments. And at this point, we should be able to check out our pet type, and we're not seeing our description yet. So number one, all of this is being added to this space. We have all of our different implementations. Let me try restarting to see that this is popping over there. We can also add these to individual fields. So for example, let's add a couple comments to our customer type. So we'll say, this is a unique field for a user's name. I don't know how good that is. We'll stick with it. So let's get our customer back. So something we also have access to is the schema search. So if you, like I am, are scrolling around like an inefficient person, you can always search for customer, and this will pull this up. The interface documentation should be in the introspection panel. Yes, it should. Okay. So backing up a step, this is how we would add those comments or documentation to our types. And then for each individual line, I typically just use the single line quote for that. I'm struggling with why this isn't showing up. Yeah, exactly. Double quote is valid for a single line description as well. Absolutely. So if you prefer that syntax for maybe the entire type, go for it. Certainly. The other thing we wanted to look at was our customer. So the customer, we had a username. There we go. So finally that popped up for us. How sweet is that? Similarly, we probably want to take the step of adding this documentation when our schema is in pretty good shape. So what do I mean by that? I mean, like, once we are as a team feeling like the schema is in a shape that's ready for production, or at least ready for robust testing, taking the step to write some documentation is usually a really nice idea. So highly recommend that. Okay, let me show you a couple other things about our mocks here. So because I wasn't getting this to reload before the break, I wasn't doing a particularly good job explaining what these mocks were doing. So I'm going to try that again. We're going to pass these mocks into our Apollo server as an object. So for each one of these types, int, string, and date, I'm going to say, instead of using the mocks that are part of the default library, use these values instead. So here in our Apollo Studio Explorer, we're going to look for, say, I made that query and that's a weird query. So let's say all pets, and then we'll look for our name. So for name here, this says cool pet, which is kind of silly. So cool pet is what I'm returning as a string. We're just basically saying anytime there's a function for this field, go ahead and call that. So we're replacing the defaults with the mocks object. Now, a lot of people have asked the question, why is it that when I send a request for a list, I'm only getting back 2 values? That's kind of frustrating. What we can do with this is we can import from Apollo server this value called mock list. So the default is always that if we're returning a list, it's going to return 2 objects. If I incorporate the mock list constructor, or the mock list class rather, we can, inside of here, we can say query, and then an M is not a comma. We'll say query, and then we'll say all cats. There's something that's really important to note about this is if you're nesting different objects in here, if you're nesting different fields in here, everything you need, every field that you add needs to be mapped to a function. So check it out. I'll say new mock list, and then let's pass in 5. Okay, so the other thing I'm doing wrong here is because this query is returning an object, I need to do the thing that I always see bugs in code about, which is we want to point our arrow here at a set of parentheses that's wrapped around an object. We're actually returning an object filled with custom functions here. So this is what that line 14 looks like. And I'm going to copy and paste this into the chat just so that we have it. That looks really good, right? Not really, but we'll try that again. And let's see why our mock list is abandoning us. Interesting. Hmm. Oh, haha. All pets. Everyone is like, hey, mock list is not a constructor. Okay, fair enough. Yeah, sometimes you want just the cats only, right? That's what that felt like to me as well. All right, so maybe something has changed since I last saw this. Oh, hmm. Interesting. So I think mock list is only working with, let's see if that works. No, it totally doesn't. So it may not be part of, oh, it does? We're learning a lot today about the mock list. Okay. That's good. I feel good about that if it's not working for you. So I think the newer way of handling this actually, and this is good for us to explore together. Yeah, deprecated, use plain arrays instead. Fair enough. We can do that. I feel good about that. So what we can do instead, they burned us, they deprecated us, but we won't panic. All we need to do is this. We'll just use JavaScript. That's actually better because we're not importing something that we don't really need. Because JavaScript is our friend and we can do this. So we'll say new array. We'll pass in maybe 3 or let's say 10, not 310. And let's give that a try. So we will refresh, excuse me. We will run it. And I feel good about this. We got our pets. How cool. So let's live in the now. We'll live in the modern future where we don't have the mock list anymore, but instead we create a new array, and this will create that list for us. Pretty cool. All right, something else I want to show you is if we want to add on to our mocking capabilities a little bit. Yeah, so if you wanted to pass in a different value here, you could. It's just whatever number you want to create. Yes, rest in peace, mock list. We'll miss you, but but we won't miss you that much. We'll be okay. Um cool. Anyway, so our next thing that we want to take a look at, just laughing at my own jokes, as is my custom, is we're going to stop this server for a second. And let's incorporate a library that generates some fake data for us. So you could use Faker for this. You could use something called Casual for this. And what we'll do is we'll say npm install casual. And once that is installed, and let me type that into the chat, this opens up some even more cool possibilities for us. Npm install casual, sorry. Yeah, exactly. Javier, if you're using Apollo server version 2, you can you can still get away with mock list, deprecated in version 3. We are at 3.5. So this is why we had to send mock list off on the ice flow. JavaScript question, why do we need the spread? You just get all nulls with new array n. So let's take a look. If we get rid of the interesting, failed to fetch because I stopped it. So value to set in query, we get this strange error. Basically what we're doing here is we're pushing some new items into that array. We're creating new, and the square brackets he meant. Yeah, let's take a look. So you want to go this route without the, like that? Let's take a look. We get a bunch of nulls, right? So basically what this is saying is we need to put this into some sort of new array. This error that we're getting is not pushing in all of those values. So yeah, we're pushing all of these values in here. So the new array 10 gives you an empty array with a size of 10. Exactly. And then what we're saying is create some mocks inside of there. Yeah, not with 10 empty items. So that'll give us access to all of those fields that are part of each one of those pets. So I too think that syntax is a little kooky, but we're going for it. So basically it's just saying make an array containing a certain number of copies of that item. Cool. So I promised to talk about casual, and then we started to talk about the spread operator a bunch. So we're back to where we were. Chris is coming clutch with good explanations. I like it. We're going to, Patrick even typed it out. Ooh, Brian, array from. I like that too. Yeah, that's a cool thing about programming. And also the worst thing about programming is there's more than one way to do something. Anyway, let's incorporate casual. This is our last thing that we'll talk about here for mocking, unless there are other questions, which there are already, so maybe not. We want to incorporate this casual library. So we'll say const casual equals require casual. Should I have deleted this? I should not have. Okay. What I'd like to do next is we're going to scroll down a little bit. And for our, let's say for our okay, for our ints, this will generate some sort of a random number between those numbers. We need to also restart our server and not delete read file sync. So No, that's really bad. What has an int? One of those things we could just incorporate that there. The final thing I wanted to say is you could also pop this in here. So you could say casual.integer and generate some sort of a random number. So that's a possibility as well. Lots of different paths toward the same results. Folks are getting ready to move on. So that feels like it may be time to do so. But I just wanted to reiterate that what we were really here to talk about, even though a lot of questions popped up about mocking, was that iterating on a schema as a group is probably one of, if not the most important conversation about working on a GraphQL project. I think that our interface is a great way of setting that up. We can create different union types as well. So union types will allow us to query different things. We've talked a little bit about the different types of pagination specs. And the final thing that I want to talk about is this. So let's go ahead and add to our customer. We're going to add to our customer a location. And let's say that this location was already in our schema. So the next thing I'll do is I'll create a type called location. And instead of making this a string, like it would return Tahoe City, California, we want to update this to be an object, a custom object with a city and with a state. A US centric example, but we get the idea. Now, the next thing that we can do here is we can say that the location itself is a string, but this is a field that's been deprecated. And the reason for this, and we'll say use location details, city, state instead. So with our deprecation, we have a reason that will pop up in our Apollo Studio or in our Playground or Graphical or whatever that is. From here, what I can say is location details should be set to location. So, and I should make that not required. So anytime we're trying to iterate on these values, it's harder to remove things from a schema than it is to add them. So this is what we're doing here. We're saying, hey, this field doesn't exist anymore. It's deprecated. And then the location details should return that object. So the backticks that we're using here are actually going to be used for this. Check it out. Okay. Let's go back to our API here. We're going to look at the username. And in the context of the sandbox here, it doesn't highlight this name. But if we were using like GraphQL Playground, it gives it a nice highlight. So maybe that's a future thing we could talk about for Studio. It's a good idea. David asked, does anyone have a good naming strategy when you need to change an output type, but you already took the most sensible name? Good question. So in this case, we have just given it a different name, even though location might be a better might be a better name for that field. You could say something sort of related. But does anyone have anything better that you might want to use instead? Totally. So what we can also do here in our response, let's take a look at that. And other folks are mentioning other questions, so feel free to participate in that. So, what I want to show is a quick example of a custom object. So, the location itself is returning an object. Throughout our schema, we can define custom objects that will represent different types. And these custom objects can be used as responses to queries and to mutations. So, what's really nice about this, and I'm sorry that I'm taking forever to find this, I have a point. Okay, is a nice thing that we could add here. Let's say we wanted to say create account, right? And create account should return a union that is an account payload. And this should return either an error or a customer. And then the type for error is a message that's just a string. Remember, just like in the case of our family pets, a family pet in this array will return either a cat or a dog. For our union type of account payload, we can, for the mutation or for any of our queries, we could return this instead. And what this is going to return is it's going to return either an error or a customer. This is based on a pattern that has gotten pretty popular in the world of GraphQL. I will share with you a great talk. It's like one of the more popular ever. Sasha Solomon gave this awesome talk. She works at Twitter, and there's a blog about it. And this is one way of approaching this. And there are, of course, other ways of handling GraphQL errors as well. But this is just one of them as it relates to the schema. So I wanted to take a second to talk about it. All right, so we've talked about schema design. When we return from our next break, we are going to talk some more about how we work with some of these Apollo tools for checking in and checking out our schema. So we're going to take a look at the Rover CLI. We're going to do some configuration. We're going to set up accounts. We're going to set up dev graphs. We're going to attach our CLIs to live sites and use this to do a lot of cool stuff. So let's come back here in 10 minutes. I know folks have questions, but I will answer those as soon as we get back from the break. Thank you all so much for being part of this class. I've had so much fun so far, but there is more to come. So more to come in 10 minutes. Have a great break. All right, welcome back, everybody. I put on the coat because I got cold. How are we feeling out there? How are we feeling about GraphQL, about Apollo, about life in general? Hopefully good. In the final section of our course together this morning, we are going to talk a little bit more about kind of some of the developer tooling that we have access to with Apollo Studio and with Rover and things like this. This afternoon, we are also doing another course on Apollo Federation. So we'll dig deep on that this afternoon. We'll build our own federated GraphQL API. So don't forget about that. A couple questions that have come up. There's a question about the Apollo server with mocks versus the Apollo mock provider. So most of my experience with mocking is on the server, but the mock provider is used to mock data for the client. So a really good use case for using a mock provider is when you don't have access to your server and you want to just mock things on the client side. It's also really useful if you're iterating on a client project that you're working on. So that will be part of the picture as well. So mocks on the server are what we demonstrated here. The mock provider is how you can basically test your React components. So yeah, exactly. So as you said, the mocked provider is a React component. I'm going to share a link to your, or to, I guess it's your docs, to all of our docs. America. What am I talking about? So anyway, this is what we're doing here. This is kind of the front end version of this that you can use for React. So if you have access to the front end, this is what that's all about. Daniel asked if we're going to use Federation version 2. Yes, we are definitely using Federation v2. Federation version 2 came out last week, but it doesn't mean that we shouldn't learn it today. So it's very exciting. There's a lot of cool new features that we can take advantage of. So of course we will be using the latest. All right, so if we use stored procedures to get data from a database, how will we leverage the GraphQL advantage of getting only specific fields, since the stored procedure might return a lot of data, but GraphQL will return part? A lot of that comes down to your front end caching, a lot of benefits that you get from that, where you cache the results of maybe a restricted list of fields where you're not making round trips to your server. So that's a good way of handling that. Okay. So a lot of great questions popping up. There was a question about subscriptions as well. We're not going to go into subscriptions too much, but I do have some good resources for that. The whole idea of a GraphQL subscription is that, in short, they work over WebSockets and allow us to listen for data changes in real time. A good example of a GraphQL subscription, or a simple example of a GraphQL subscription, is this vote activity. So this will be fun. Data loader from Facebook is a pretty great tool. Yeah, definitely check that out. Check out Apollo data sources as well as a way of handling the responses from a REST API. I know that's not what you're talking about with the databases, but yeah, excellent idea. Just a quick look at a GraphQL subscription in practice, and I will encourage you all to play along with this. Here's a quick example of a small voting application that has results for Alex and Eve. Back when a lot of the conferences were live, at a live conference, I was hosting with my coworker / husband, Alex, and we put it up to the audience to vote on who should be the MC of the conference for the rest of the day. So Jenny, you had asked, are those data changes only to the GraphQL server, or can it detect if there was a change made from another source? Team Alex, I love it. Yes, I'm Team Alex too. Talk to my therapist about that. But we'll go ahead and we'll look at this query. This returns an object of results for Alex and Eve. Then when we send a mutation for voting, see Eric, Team Alex, we're going to vote for this person a couple different times. This is going to change the data of the application. So if you want to send your own mutations, if you want to follow along with that, you can. Oh, sorry. Get back to where we were. So with our vote mutation, we are going to execute these mutations for any time we want to issue another vote. Now, queries get data, mutations change data, subscriptions listen for data changes in real time. So if I issue a subscription for a result, right, it's going to set up this listener. I'm listening for any of these data changes. And because you are all a great audience, you're voting and you're making it look like the app works. So that's very exciting. So as these new events come in, as these mutations come in, it's going to change the data. So think about a query and a mutation as working over the HTTP protocol for the most part. We're sending a request and we're getting a response. With a subscription, we're listening over a WebSocket. So I think about a subscription as being like I'm making a call, right? I'm calling Conrad and I'm saying, hey, can you tell me the most recent changes to the vote tally whenever you have it? And I'm just going to hang out on the phone here. Versus being like, hey, Conrad, what are the results? And then I hang up the phone and he calls me back and tells me what those answers are. So subscriptions are really a powerful construct in GraphQL. They were first used, we should be looking at the election. They were first used in production at Facebook for those live likes that you see on posts. So every time someone likes a post, you see that thumbs up graphic changing in real time. Similarly, when you have those floating emoji heads going all over the screen, that's powered by, in those live videos, that's powered by GraphQL subscriptions as well. And then there's a great question here. There's also a live directive for using that versus a subscription. So typically our subscriptions will, yeah, exactly. So subscriptions function independently of people calling the mutation. It's up to you how you activate a new send of data based on an on change. So yeah, typically this will respond to a mutation, but it doesn't necessarily have to. You just need to trigger some sort of change. Okay. So that's an aside about subscriptions. I do take requests. I'm going to close this in 5, 4, 3, 2. I was hoping Alex would win. 1. All right. Thanks for voting. That was fun. We had fun. All right. So who is Alex and why is this election so close? So Alex is my coworker / husband, and he and I were hosting a conference and we built that very silly app. So has anyone here ever set up a system with subscriptions integrated with Kafka? I assume that someone has, because that is a very powerful thing. I've used Redis a lot for subscriptions and creating kind of a store for that live data. There was a question about the live directive and using that versus a subscription. So remember the GraphQL bleeding edge playground that we looked at before? I'm going to pull up a link to that now. That's a place where you can test out those live queries. So those work a little bit differently than subscriptions because they're just going to populate the most recent data. But if you want to play around with the live directive, check out that playground for more. And let's see. There's also this live query. There's also this live query repo that digs into a little bit more detail for that, which is pretty cool. So if I had a REST API that was referencing from GraphQL and another and another service was updating via that API and not GraphQL, the subscription would listen for those changes as well. Yes, so long as you add to your subscription rather, as long as you add that to your function, that will work. What I'm going to do is share with you the code for that voting API. And I'm going to try to remember what it's called. Ooh, first time's a charm. So this is an older app. I'll be honest that this is kind of a little old. So we have Apollo client and server 2 hooked up here. But the vibes are the same for the modern version 3 of both of those. So If you check out the API folder in this project, I'll share with you the whole repo in 1 second. The API folder has an index file where we're using pub/sub via Apollo Server Express to make this work. All we need to do to make the subscriptions work is first add it as a type to our schema. We then add it as a resolver. And as you mentioned before, I think it was David who said, we have a subscribe method that's part of our resolvers. And these are going to use this async iterator function to iterate through the different listeners. So you can use this as a possible example. There's also a front end, which probably uses those older subscription components, but this thing still works. And what's cool about this is even though we were using one instance hosted on a free Heroku dyno, someone basically wrote a program to DDoS this election and voted like tens of thousands of times, and it never crashed. So there you go. Very exciting. So that's that on subscriptions. I can totally send you some more resources on that, Jenny, if you're interested. I have more samples and things like that. I'll make a little note to do that. If you send me an email, that will help me remember to do that faster, but that is on my list of to-dos. Okay. And Trevor said, almost had the auto cannon set up. I know, you should have. Never too late to get that going. All right, cool. So that is a lot of conversation about a lot of things. Inside of our Rover and Studio folder, I have a folder for the pet library that's basically just using some basics. We have some mocking set up and things like that. FYI, voting is still going on. Awesome. So yeah, we'll shut down voting when we feel like it, I guess. That's so funny. Oh, another thing I wanted to share. The voting never stops. All right. So something I wanted to share was a resource in the chat from before the break, this GraphQL rules website. This is one I've never seen. So thanks to whoever shared this. I'm sorry that I don't remember. I'm scrolling up, trying to remember. It's happening. Okay. Reading is hard, but this is a great resource for some different schema tips and tricks. So check that out if you're interested. So I can't take credit for that, but I'm passing it along in case folks missed that in the chat a little bit earlier. Okay, so we've talked about schemas. We've talked about defer and stream. We've talked about some examples of subscriptions and some other tooling tips along the way. The final thing that I want to discuss today in a little bit more detail is how to work with Apollo Studio and Rover for graph monitoring. If you haven't set up your Studio account yet, I would encourage you to do so. We can do that by going over to, and let's get our toolbar back. We're going to go to studio.apollographql.com. You can log in with your GitHub account, and you will probably be taken to a screen that looks something like this. So let me share that link with everybody. It's also in your student files. And if folks are joining late, there is a list of resources in this repo here. So let me just share that also. Okay. So in our list of example graphs, we have a ton of deployed graphs that you can check out, which I think is a useful exercise always to see how other folks are setting up their own projects. And then the whole idea of Apollo Studio is not only does it give you this awesome interface for sending queries with the Explorer. So we saw this already. I'm just going to my example here, and you can use one of those sample graphs if you'd like to. We're going to open up the pet library here, and this will show us all of the different features of Studio. Number one, it's a schema documentation portal, essentially, where we can see all of the different queries, mutations, etc. for our application. We also have this nice Explorer that we saw already, but this is integrated into Studio as well. It doesn't just run alongside Apollo server, it also runs here. Moving down a little bit further, we have fields. So fields are showing us like how many times are people hitting this particular field. This is really nice for also checking out like a history of that schema. So earlier this morning, I pushed an update to this schema, and it's showing me like everything that's changed. Descriptions have changed. We removed a field, the category field. We've added fields, and this will keep track of all of these different changes. So this gives us insights into our graph. The conversation used to be, and I have a ton of these APIs out here in the world because if someone hacks my pet library API, I care but don't care that much because there's no personal data here or anything. But in the earlier days of GraphQL, the common idea was that, oh, we should just make our API public and everyone can consume it. And then everyone's like, no, we don't want to do that. That seems really scary. So more often than not, you'll find that introspection or the ability to make all of our fields in our schema visible will be turned off. But we can manage our schema using Apollo Studio instead. So in addition to this nice user interface for dealing with our schema, we also have access to a really awesome tool called Rover that's going to allow us to continually push new changes to our schema in order to collaborate on it as a team. So let me show you what I mean by that. We're going to open up, I'm going to share with you this documentation for installing, because if you haven't installed Rover before, it will be a good idea to do so. So I'm going to put this up on the screen for a moment. I'm going to share this link with everybody in the chat. And Rover is a tool that is a replacement for an older tool called Apollo CLI. So Rover has a lot of cool features. It has a lot of exciting kind of integrations with federated services as well, which I'll talk about more this afternoon if you are interested in coming to that session. But for the moment, I'd like you to ensure that you have this downloaded. So what I'd like everybody to do is to, you can run this with curl if you'd like to. You can also install this with NPM. So you could install this to your dev dependencies of your project. You could install it globally. There's a lot of different options for installing it, but I'll shut up for a minute and you can take a second to make sure that that's downloaded. So Emmanuel, you had asked the question about being able to only see a couple of those features. So let's see. So a couple different things here. If you can only see a few of these features, it's likely that you haven't been able to set up your server to interact yet with this API. So I'm about to show you some cool ways of being able to push your schema to Studio so that you can do more monitoring. Another question that's great here for the monitoring feature, does the data go through Apollo servers? I would guess so. I'm working with health data, and due to Hipaa constraints, I'm not sure if it's used for monitoring purposes. That's a really good question. If what I would assume is the same thing as Jenny, which is that Studio doesn't get the actual response data, just the metrics. So we would have access, as we see, to these fields, but not to the actual data that's being returned. If there are some Apollo folks on the chat who know a little bit more about the Hipaa and GDPR considerations, I'm going to shout you out because you might know more than me. But I would say that for the most part, we're dealing with the fields themselves versus storing the data. The metrics are really to tell you how long does it take to fulfill these queries? How long does it take to ask for certain fields? Am I asking for a field? Let's say I'm asking for a biography field and it's really called bio. That's going to be different. So thank you, Juan, for that awesome question. And I'll make a note to follow up with you on that because that's a great question. Other things, unsupported engine. Let's see. I think that could have to do, Christoph, with your version of Node. You may need to roll back to a previous version. I think I saw recently that we may need 12 or 14. So what you can do is you can use NVM to change that version and see if that works. And if that doesn't work, try installing it in the project itself. Yeah. Let's see. Because I don't want to, works for me on version 12. If anybody else is getting those errors, what I'd recommend you do is I'm going to navigate to the pet library folder, zoom, CD, drag it over there because I make typos a lot, and then we'll run npm install. And then you can just try to configure Rover in your folder here. So you could run npm install -- save dev at Apollo/Rover. Yeah, Steve, I saw that too. I was trying to find it on my side screen, but it wasn't coming to me, but it works for version 12 and 14. So if you do type node v and see 16 or higher, check that out. What else? Let's see. So folks who are interested in more on that Hipaa data thing, because I don't have your email address and because I don't want to ask you to type it into a public chat, I will type my own into a public chat because that's not very secret. Cool. So yeah, if you're running, that's what I thought, Christoph, about you running 16. I think that's interesting. Yeah, lots to try. Try to install that in the folder itself versus the global install. I love that folks are suggesting other versions of NVM. That's great. I wish you well on your journey with whatever tools you choose, but I'm here to show you a few. So what we're going to do next is we'll talk about how we can set up our environment using Rover. So we have Rover installed in some capacity. Ideally, it's in our pet library folder, or we've installed it on our system. So I installed it via curl earlier today, and that worked pretty well. Another thing to do once you have installed that is to close and reopen your terminal. I've run into a bug with that before. Not a bug, but it doesn't have it in context. It isn't added to the path until we reopen the terminal. So just a quick note on that. So once we've installed this, our next step is to configure Rover to work with Apollo Studio. I'm going to head back over to Apollo Studio. And oh, nice. Brian hooking it up. Data privacy. Very cool. So that will be something I'll add to our list of student links as well. So throwing it out there. Okay, so the first way we want to get started with our project here is to go to our pet library folder. We're going to run an npm start. And this will run our server on localhost 4000. So we should be able to, and that popped open over here, that should be able to open this up in our, there we go. Should be able to open this up in our local sandbox. Now, one way that we can utilize the functionality of the of Apollo Studio and Rover together is to set up what's called a dev graph. So think of a dev graph as being a studio tool for local versions of our apps. So the way that we set this up, no matter what context you're in here, you're going to click on New Graph. Now, New Graph, I have a few different organizations here because I'm disorganized. More organizations means you're disorganized. We're going to go ahead and give this graph a title. And the title of the graph will be pet info. This will create a custom graph ID for you that you can set to be whatever you want. There's two types of graphs. So we have deployed and we have development. So the development graph is going to just look for localhost 4000 or whatever custom version you've used. Something to note is that if you are setting this up, and let's try this again. So I'm going to do the whole thing again to try to break it. So if you are trying to create this graph and you don't have the server currently running, you need to have it running. So start your graph up again. And then this should work for you. All right, cool. So we're back. We're going to create our graph. And this should run our graph locally. So we can run all of this locally with our server. So that's obviously a quick first step for that, but realistically, we probably want to do a bit more monitoring of this. So here's what I want to do. I'm going to go back to our terminal. And we're going to make sure that we're in the correct directory. As we know, I can't navigate to a directory without using this tool. I can, but do I want to? I don't. Does this even work? It sure does. What a life. Okay, so we're navigated to the correct spot. What we want to do next is we want to type Rover. Let's just type Rover first. If it says command not found, try two things. Thing one to try, close and reopen your terminal. Thing two to try is to maybe install Rover locally in your project. You could also try typing npx rover, and that may work as well. And this will just, as you know, probably give you some sort of a list of all of the commands that Rover will allow for you to use. So check this out. I'm going to type rover config auth. This is going to ask for my personal API key. It's going to ask for an API key to get us started. So what I can do is, I'm going to kill this for a second. I'm going to use this link. I'm going to use the awesome developer experience that Apollo is providing for us to create a new key. So we're going to create a new key. I'm going to call it awesome class key. This is important. Don't delete this key or don't close this window because you won't be able to get it back. As this says, make sure to copy your API key now. This is not a joke. You're not going to be able to come back here and get it. So you can always generate a new one. It's not a huge deal. However, it's a nice thing to grab that. Everyone can see my API key. So that's terrifying to think of what you could do with that. And we're going to go ahead and say rover config auth. I'm going to paste that link. It's going to paste, and it doesn't look like anything has pasted, but it has. We're going to hit enter. And then this will say that I have successfully saved my API key. Okay. How is that going for everyone? There's a little bit of a lag every time I ask a question, so there's a lot of suspense for me. I'm hoping that that is going well. So we should have saved our API key in that way. It's also possible to save your API key using an environment file. So you could, in your project, add a .env file. For this, you're going to say Apollo _ key and set that equal to whatever your key is. Now, it's important to know that the Apollo key in the environment file is going to override anything that you set up using the CLI. So that's really important to note. This will take precedence over the one that you set with your configuration profile. Okay. So there's another question here, only copying the latter part of the full string. It should be the full string. So you're going to have a user, and then you're going to have the value over here as well. So it's up to you where you want to put that. If you're using a CI process, which you probably will be at some point for your project, it's probably a good idea to configure that in the environment file. But love it. People are in, they're wearing sunglasses. I love it. There's a question here about the student list of all the links that were shared. Yeah, so not only will you have access to the links that are currently there, I'm going to sweep through the chat after this and make sure that everything is posted as well. Yeah, GH meaning GitHub, exactly. Okay, cool. So we have created our connection with Studio at this point using Rover. Sorry for touching the microphone. Very unprofessional. What we're going to do next is we're going to, inside of our type definitions, let's make a couple changes. So I'm going to change I'm just going to delete some stuff. This is scary, right? If someone came in and started doing this to your actual API, this would be a full nightmare. But that's what we're here to do. Cause chaos. We're just deleting some stuff at random to feel alive. The next thing we're going to do, if we go back to our terminal, there we are, is we're going to check in our schema. So what's cool about this, and we can run this, and let me share the link for everybody. There's a nice little list of common commands that you can take advantage of right here on the main Rover documentation site. This will, if we look at our CLI, we're going to do this. So these are some of the common tasks, the common commands that you can run using Rover to publish your schema. So the first one here is how we might publish our graph schema to Apollo Studio if we had our schema in a local file, which we probably do. But we're using the schema document itself to publish this. So this is a really good option if you have a file that ends in the .graphql or the .gql extension, right? Then use this one. You also can fetch your server schema by introspecting it. In other words, you're going to send a version of the schema that you've gotten by having Rover look at whatever your schema is that's currently hosted here. So yeah, just me deleting a bunch of fields is not very production ready. However, me iterating on a schema or having a bunch of people iterate on a schema together and then pushing that to Studio as a schema check-in, that is super production ready because it means that Studio becomes the source of truth for your source of truth. In other words, the GraphQL schema is this blueprint for your entire app, but Studio is the place where everybody can collaborate and work together and ensure that by me just deleting stuff and being a full animal and ruining my schema, I'm not going to cause too many problems because in Studio, I'll be able to ensure that everything is working. Okay, so a couple things. We want to make sure that we're at Studio. So this is our schema sandbox that's running locally, but we want to take a look at the pet info dev graph here. And if we look at this, let's see. If we look at this here, this is showing us a change log of all of these different changes that I've made. So let's make sure, and I'm like totally not in the right thing. So here I've created my personal settings for this project. So we're in the Moon Highway graph here. And we're also using this pet info project here. Now, what we want to do inside of this is we want to publish our schema. We want to publish all of these changes to the appropriate spot. So what I'm going to type here is the thing I typed before. We're going to type, or the thing we saw before. We're going to type Rover graph publish. And then we're going to make sure that we're publishing this to our pet info. So, sorry, trying to find, okay, we're trying to find our little graph ID here. So we're going to publish this to the graph title and the graph ID. So let's go ahead and look at this. All right, cool. So we'll say pet info at pet info, all that stuff. And then we'll say dash dash schema type defs dot GraphQL. Okay, cool. So now, because I typed the wrong thing, because I sometimes type the wrong thing, what we're going to do is follow the instructions of this. So check this out. We're making sure that our graph name is correct. If you don't know what that is, I don't, we're going to ask. So Rover is helping us out in such an awesome way. Rover config, who am I? This is going to check the identity of that graph, and we're going to get it from here. So let's check again. This will show us our API key. It'll show us our user ID. It'll show us our origin. So let me pull up how we get that graph again. Aditi, I agree that we need that. Let's see. Cool. So let's go back. We're going to go to, sorry. I'm going to make this happen. It's very exciting. Okay. Let's try this one more time. So we're going to go to our graph title. I think this should work. And I'll go over this again one more time. I just want to make sure that I'm not messing up these instructions for you. So let's try this. We'll go up because we are lazy. So we'll say pets. And we'll say at current. U8EY8I. There it is. Awesome. So let's try that all again. It's happened. And probably if you've created your graph from scratch, the variant that you're on is called current. So the way that you find this, and it took me a minute. The way that you find this is you're going to click on your graph. You're going to go to the settings, and then you'll use the graph ID, and you'll use that with the at current symbol. So let me share with you what I just typed so that we all have it. We have so many screens happening. But this is how we're going to be able to publish our local version of the schema. So this is what that looks like for me. The part that goes before at current is going to be a little bit different for you. But that should work nicely. So what's cool about this is if we take a look at our Explorer here, this should show us the changes that we've made. So at 11:18, I went ballistic. I caused a lot of problems. I changed types. I deleted stuff. I did a bunch of bad things. And Ben, if you're seeing no changes, let's see, make sure that you're pointing to the right file. Make sure you've sent that schema flag. Make sure you've saved your file. And if all of those things don't work, just let me know. So this is the powerful conceit of working with Studio. The whole idea here is that we're using Studio as a tool for collaboration and a tool for organization. Nothing is more important in a GraphQL project than a schema. If we're breaking our schema, then we're breaking our apps. So this is going to give us a lot of insights into exactly what's going on here. So Rover is going to help us with checking in our schema this way. We also have the ability to introspect our schema, as we saw, from a running project or from a local version. So you could pass localhost GraphQL, or you could pass a working API like this. Sometimes it's useful to check out how you might do a schema check with a URL. So you could always do that with this global version. And then again, if you're going to be part of this afternoon's class, you could also use the super graph compose feature. And we'll show you how to do that this afternoon to put together multiple subgraphs and check those in. So a lot of awesome features that work really nicely with federation as well. Okay, other things, I can see my changes in the changelog, but can't see the changes in the SDL or reference. So the changelog itself is going to let you know what has changed. The SDL will just give you a read of what is your current schema. So there won't be any notes here about things that have changed. And then also the reference itself, same goes for that. So I hope that answers your question, Andrew. If not, just let me know. Okay. So we are dangerously close to the end of our time, and I like to respect people's time, especially if lunch is involved. So I want to point out again that everything we've talked about thus far is here. And I'm going to add to the bottom of this list a list of all of the links and resources that we talked about today. So any extra notes, cool resources that our other collaborative students have shared are going to live here. There's also a demo of some client-side batching that you can take a look at too. And I will add to our list of error handling as well. So we saw how the error handling pattern works in the schema, but we can talk more about, or we can add more about other things too. I also want to pull up our slides. Remember all of this? And I just want to say thank you to everybody. I know that there will be some more questions, and I'm happy to hang out and answer those. But I want to thank everybody so much for being part of this class today. It was a lot of fun to go through some schema design stuff and some introductions to new spec features, as well as how do we start to think about how to manage our schema as a team. Always feel free to send me emails or questions. You can send those over at eve@moonhighway.com or find me at Eve Porcello at most places. And that's about it for today. I want to thank you all so much for being here. Join us this afternoon when we'll go deep on Apollo Federation, and we will be using Federation 2, not Federation 1. That is so last week. Federation 1 is today. So thank you all so much. I really, really, really appreciate everything that you helped with. If you have localhost running, your schema is being restored by Studio. Gotcha. So yeah, we can use the localhost 4000 option versus the static schema. Good call. Awesome. And if there was a question that you had that I didn't get to, feel free to ask it now. I'll do my best to answer those. If you want to send those over to me, oh yeah, we should check who won the voting. If you want to send those over to me via email, though, that's fine too. Thank you so much, everybody. The Apollo community continues to be the best. So I appreciate you all. What am I looking up? Vote.moonhighway.com is what I'm looking up. Application error. That's hilarious. We crashed that sucker. Yep. We crashed the service. Isn't that cool? Oh, what a treat. I'm just going to close that. That may be restarting. Awesome. What's the story behind the name Moon Highway? That's a good question. It came from the Valley of the Moon in Sonoma. That's where that first came from. And who used a cannon to vote? Great question. Too much voting. I'll have to look at what that is. If you're coming this afternoon, I'll try to figure out what that is crashed for. Check those logs. Some error handling. We talked about the way that we could handle errors with the union types. Yeah, the unions are one of those ways. There's also error handling. It really is a full stack conversation. There's error handling on the server, which we handle with a lot of usually conditionals to make that work. There's also error handling on the client, where Apollo client gives us a lot of error handling, particularly with the error link. So I'm going to share with you some client ways and some server ways of handling that. Apollo server errors. And I'd be happy to share some more resources on that. I'll add these to our student files as well. I think a good way of thinking about this is captured in this error handling doc from Apollo. And that's to think about kind of what are the different types of errors and how do you want to categorize them? Do you want an error to completely stop your components from rendering or not? Do you want to capture those in different ways? Oh, interesting. You're coding a graph with Prisma and Apollo, and the Prisma errors get in the way. Yeah, that's really interesting. Why don't I do a little more research on best practices for that stack? I think that's a good thing to look at. If you want to send me an email, I can respond directly to you. I don't want to pressure anybody to drop their email in the chat because that's unkind, but I will follow up with a little bit more on that topic. Yeah, I think categorizing errors is super important and thinking through like what kind of error does what. And it's an evolving story, I think. I look forward to seeing you in a future session. If I answered a question in a way that was insufficient, always feel free to get in touch. But I thank you all for being such a great class, and I look forward to seeing you again, hopefully this afternoon. Have a great rest of the day, everybody.